Begin with a number that should not unsettle you, but does. In 2 dimensions, there are exactly 4 of them. In 3, 9. The pattern is the square of the dimension, a simple count of perfectly balanced measurements. And for reasons no one has fully explained, this small number may sit closer to the floor of physical reality than atoms, than fields, than the empty space you imagine those atoms float in. For a century, physics searched for the world as it is when no one is looking. A clockwork that runs whether or not any eye is turned toward it. And yet the most precise theory ever written, quantum mechanics, has never stopped misbehaving when examined too closely. Its central object, the wave function, refuses to sit still. It collapses the instant a measurement is made. And physicists have argued for 90 years about what exactly physically collapses, and where, and when, and for whom. There is an interpretation that answers all of this by refusing the question. It says the wave function was never a thing in the world at all. It is a tool in the hands of an agent, a personal expectation about an experience not yet had. This is Quantum Bayesianism, QBism. And behind it stands an older, stranger idea, that the raw material of reality is not matter, but experience itself. Stay with me, and you will see where this idea came from, why a measurement might create rather than reveal, what an unsolved problem in pure mathematics has to do with observation, and where, in the end, the structure quietly cracks. If you find value in explorations like this, the subscribe button quietly helps these deep dives reach more curious minds. So, here is where it begins. To understand QBism, you have to go back further than quantum mechanics. Back before the equations, before the laboratories, to a question asked by a philosopher who never solved a single physics problem. The question was this: what is the world actually made of before we start dividing it up? The philosopher was William James, American, born in 1842, dead in 1910. He is remembered today mostly as a psychologist, the man who wrote about the stream of consciousness and the varieties of religious experience. But in the last years of his life, in a series of essays written in 1904 and 1905, James proposed something far more radical than anything in his psychology. He called it radical empiricism, and its central claim was a quiet act of demolition. The claim was this: the world is not divided at bottom into minds on one side and matter on the other. That division, the split between the observer and the observed, between the subject who experiences and the object that is experienced, is not the starting point of reality. It is something that comes afterward. What comes first, James said, is pure experience, a single, undivided stuff, plain, unqualified actuality. He used a striking phrase. The present field of experience, he wrote, is a simple that, before it is sorted into the what of an external object and the who of an internal self. Consider how strange this is, and how ordinary. Right now, you are having an experience. There is a field of color and sound and sensation. Common sense tells you this field has 2 parts. There is the world out there, and there is you in here looking at it. James asks you to notice that this division is something you do to the experience, not something you find already inside it. The experience, in the raw, is just there. The subject and the object are two ways of taking the same pure experience, taking it, in James's word, twice. Once as part of a chain of physical events in a room, once as part of the history of a mind. The same patch of green, the same note of sound, can be filed under the world or filed under my awareness. And which file it goes in depends on what relations you trace from it, not on what it is in itself. James gave this a name in the title of one of his essays. He asked whether consciousness exists, and his answer shocked his contemporaries. Consciousness, he wrote, does not exist as a thing, as an entity, as a stuff. It exists only as a function, a relation between parts of experience. Subjectivity and objectivity are functional attributes, realized only when an experience is taken in a certain way. There is no little screen inside the skull on which the world is painted. There is only experience, and the roles we assign to its parts. Hold this idea. We are going to follow it across 100 years into the heart of the strangest theory in physics. But first, James had a partner he never met, a physicist who had reached a neighboring conclusion from the opposite direction. His name was Ernst Mach. Austrian, born in 1838, died in 1916. Mach was a working physicist, and the speed of sound still carries his name in the Mach number. But Mach was also a relentless philosophical skeptic, and his target was metaphysics, the positing of things you cannot observe. Science, Mach insisted, should describe the relations among sensations, among what he called the elements of experience, and it should refuse to invent hidden machinery behind them. He held a chair in Vienna for the philosophy of the inductive sciences, and the circle of thinkers who later built the philosophy called logical positivism took him as their ancestor. Their forerunner society was named the Ernst Mach Association. Mach is famous for a position that, in hindsight, looks like a catastrophic error. He did not believe in atoms. Not because he was foolish. He was one of the sharpest minds of his century. He simply would not, on principle, grant reality to something no one had ever directly sensed. Atoms, to Mach, were a useful bookkeeping device, not established furniture of the world. In 1905, a young patent clerk named Albert Einstein published a paper on the jittering of pollen grains in water, the phenomenon called Brownian motion, that gave the atomic theory its decisive confirmation. The irony is sharp. The same Einstein had, by his own admission, been sharpened as a thinker by reading Mach. Mach's critique of absolute space, of absolute time, of unobservable structure, fed directly into the relativity that overturned Newton. Mach taught a generation to distrust the invisible scaffolding of physics. Then that generation used the lesson to discover the atoms Mach denied. But notice what survives the irony. The instinct underneath Mach's mistake, that physics should be answerable to experience, that it should not smuggle in unobservable absolutes, is exactly the instinct that produced relativity. And it is the same instinct, traced forward another half-century, that produced the interpretation of quantum mechanics we are here to examine. The bridge between the philosophers and the physics runs through a third figure, and through a subject most people find about as exciting as a tax form: probability. The figure is Bruno di Finetti, an Italian mathematician, and in 1931 he published a work whose central slogan was almost a provocation. Probability, di Finetti declared, does not exist. He did not mean the mathematics was wrong. He meant that probability is not a thing out in the world, not a property of coins or dice or atoms. Probability is a degree of belief. It is the number a rational agent assigns to her own uncertainty about what she will experience next. When you say a coin has a 1/2 chance of landing heads, you are not reporting a hidden fact about the coin. You are reporting the state of your own expectation. This is the personalist or subjective theory of probability, and di Finetti, by his own intellectual lineage, was shaped by Mach and by the pragmatist philosophy that ran parallel to James. 3 threads, then, reaching across decades. James held that experience comes before the split into subject and object. Mach held that science describes relations among sensations, not hidden absolutes. Di Finetti held that probability is personal belief, not a property of the world. Keep all 3 in view, because in the opening years of this century, 3 physicists picked them up and tied them to the equations of quantum mechanics. And the result was a claim about reality that is either the most honest interpretation ever offered, or the most seductive error. We will return much later to which. The 3 physicists were Carlton Caves, Christopher Fuchs, and Rudiger Schack. Around the years 2001 and 2002, working at the intersection of quantum information theory and the foundations of probability, they proposed an interpretation of quantum mechanics built on a single austere move. The quantum state, the wavefunction, the object every physics student learns to write down and evolve, is not a property of the system being described. It is the personal degree of belief of an agent. It is that agent's expectation about the experiences she will have as a consequence of her own actions upon the world. The name came later, in 2009. Fuchs coined the term QBism, originally short for Quantum Bayesianism. Bayesian because of the link to that subjective, belief-based reading of probability that di Finetti had pioneered. Fuchs has joked about the label since, calling it at various times Quantum Bayesianism, because, at its core, the theory is about how a rational agent should bet on her own future. The humour is real, but the proposal is serious, and it is precise. We have to be careful about what the claim is and what it is not, because almost every popular account gets it wrong in the same direction. The standard, textbook way of speaking is sometimes loosely called the Copenhagen interpretation, though the founders of quantum mechanics never agreed on a single version of it. It treats the wave function as a strange but real encoder of the world, and treats measurement as a physical event called collapse, in which the many possibilities packed into the wave function suddenly reduce to one. The dominant realist interpretations go further and insist the quantum state is a genuine physical thing. In the language of the field, they are psi-ontic, the Greek letter psi, the symbol for the wave function, treated as part of the ontology, part of what exists. QBism stands against all of this. For a QBist, the wave function is not part of the world's furniture. It is doxastic, from the Greek for belief. It lives in the agent, not in the electron. And so, the notorious collapse of the wave function, the event that has spilled rivers of ink and split physics into warring camps, becomes something almost embarrassingly simple. When an agent makes a measurement and gets a result, her expectations change. She updates. The wave function collapses in exactly the sense that your probabilities collapse when you turn over a card and see which one it is. Nothing physical snaps. No wave crashes anywhere in space. A mind revises a forecast. That is the whole of it. Keep that word collapse in mind. We have just been told that nothing physical collapses, that it is only a revision of belief. We will return to whether that is a triumphant dissolution of a fake problem or a sleight of hand that hides the real one. The QBist says the former. Hold the question open. Now, to make this concrete, consider what a quantum measurement actually is in this picture, because here the influence of James becomes almost startling. In the ordinary view, a particle has properties, a position, a spin, an energy, sitting there in the dark, waiting to be found. Measurement, on that view, is discovery. You shine your instrument on the pre-existing fact and read it off. The QBist denies this. A measurement, for the QBist, is not the revelation of a property that was already there. It is an action the agent takes upon the world, a deliberate intervention, and the outcome is a new experience that did not exist before she acted. There is a phrase that distills it, written by Fuchs together with Mermin and Schack. Experiences do not exist prior to being experienced. Read that slowly. It is the physics catching up to the philosopher. James said pure experience comes first, before the split into observer and observed. The QBist says the measurement outcome comes into being in the act of measuring, as an experience of the agent, not as a fact pried loose from an indifferent object. The electron did not have the answer in its pocket. The answer is born in the encounter. This is why QBism is so often called participatory, a word that traces back through the physicist John Archibald Wheeler, who imagined a participatory universe in which observers are not bystanders, but contributors to the reality they find. We will weigh that word, participatory with great care later, because it is the hinge on which the entire argument of this video will turn. There is a piece of vocabulary worth installing now, because it will matter. In QBism, the agent who holds the beliefs, who takes the actions, who has the experiences, is treated as primary. And yet, the theory pointedly declines to give a full definition of what an agent is. When pressed, QBists answer that they need no more definition of the agent than any decision theory needs of the gambler at the table. You know one when you are one. To critics, this is a fatal vagueness, an undefined term smuggled into the foundations of physics. To QBists, it is honesty about where the theory begins. Mark this too: the undefined agent is a thread we will pull hard in the final third of this examination, because the question of what an agent is, of what a mind is, of how unconscious matter could ever be an experiencer at all, is the question where physics hands the problem to philosophy, and where philosophy, as we will see, hands it somewhere else. For now, stay in the neutral presentation. We are reporters laying out what QBism claims, not yet judges weighing whether it holds. And the claim, so far, is this: the quantum state is personal belief. Measurement is action, not discovery. The outcome is a fresh experience, not an uncovered fact. Collapse is the updating of expectation. And the agent who does all this is left, deliberately, undefined. It sounds, at first hearing, like a retreat, as if physics has given up on describing the world and settled for describing our opinions about it. That is the standard objection, and we will give it its full force in due course. But the QBist insists it is the opposite of a retreat. It is, they say, the only interpretation that takes the actual structure of the theory at face value, without inventing invisible machinery, parallel worlds, hidden pilot waves, physical collapses, to make the equations mean something they need not mean. Whether that claim of austerity survives, whether a theory of pure belief can really be a theory of the physical world at all, is the question we are building toward. The mathematics we turn to next will make the stakes far sharper than any slogan can. To see why QBism is more than a mood, more than a philosophical preference dressed in physics, you have to look at the equation that every interpretation of quantum mechanics must account for. It is called the Born rule, and it is the bridge between the abstract quantum state and the concrete probabilities of what you will see. Max Born wrote it down in 1926, and it earned him a Nobel Prize. In its compact modern form, it reads, "The probability of an outcome equals the trace of rho times d." Spoken aloud, the probability of outcome J equals the trace of rho times d sub j. The rho is the density matrix, the mathematical object standing for the quantum state. The d sub j is the operator standing for a particular measurement outcome. The trace is an operation that squeezes the whole matrix down to a single number. And that number is a probability, a number between 0 and 1 telling you how strongly to expect that result. Every interpretation accepts the Born rule because it works. It is among the most precisely confirmed statements in all of science. The interpretations differ on what it means. The realist says it describes the propensities of a real physical state. The QBist says it is a rule of personal probability, a constraint on how a rational agent should set her own expectations. And here, QBism does something the others do not. It tries to rewrite the Born rule entirely in the language of probability, with no quantum state left visible at all, to show that the quantum formalism is, at bottom, a small and peculiar addition to the ordinary rules of gambling on experience. To do that, the QBists needed a very special kind of measurement, and finding it led them into one of the deepest unsolved problems in pure mathematics. The special measurement is called SIC-POVM. The letters stand for symmetric, informationally complete, positive, operator-valued measure, and physicists mercifully pronounce it SIC. Strip away the jargon, and the idea is geometric and almost beautiful. In a quantum system of dimension d, ASIC is a set of d-squared measurement outcomes arranged with perfect symmetry, every pair of them overlapping every other pair by exactly the same amount. The defining condition, written cleanly, is that the overlap between any two distinct elements equals 1 over d plus 1. For a single qubit, the simplest quantum system, the dimension is 2, so the SIC has 2 squared 4 outcomes, and they sit in the abstract space of states like the 4 vertices of a regular tetrahedron inscribed in a sphere. 4 points, maximally spread, perfectly balanced. The word symmetric names that balance. The phrase informationally complete names something equally important. ASIC measurement, all by itself, extracts enough information to reconstruct any state whatsoever, its outcome. Probabilities pin the state down completely. There is no hidden corner the SIC cannot reach. And this is what lets the QBIST perform the rewrite. Using ASIC as a fixed point of reference, the Born rule can be recast as a relation purely among probabilities, the agent's probabilities for the imagined reference measurement, and her probabilities for whatever real measurement she actually performs. The QBists call this rewritten law the Urgleichung, a German word meaning the primal equation, the original equation. It is worth stating, because the audience for this channel appreciates seeing the machinery, the Urgleichung says the probability of an outcome equals the sum over all the reference outcomes of the quantity d plus 1 times the probability of that reference outcome minus 1 over d, all multiplied by the conditional probability of your actual outcome given that reference outcome. Spoken plainly, the probability of j equals the sum over I of, in brackets, d plus 1 times p of I minus 1 over d, end bracket, times the probability of j given I. Look at what that is. Strip away the bracketed correction term, and what remains? A sum over reference outcomes of one probability times a conditional probability is nothing but the ordinary law of total probability, the most basic rule in all of probability theory, the rule a gambler uses without thinking. The quantum content of the entire theory in this telling is concentrated into that small, strange correction, the d plus 1, and the minus 1 over d. Quantum mechanics, the QBist says, is not a wholesale replacement of classical reasoning about uncertainty. It is classical reasoning about uncertainty bent by a single, specific, dimension-dependent twist. Think of it like a navigator's correction. An ordinary navigator on a flat map adds up distances in straight lines. A navigator on the curved surface of the Earth uses almost the same arithmetic, but with a correction term that accounts for the curvature. And that one correction is where all the strangeness of spherical geometry lives. The Urgleichung says the agent reasoning about quantum experience is using almost the ordinary arithmetic of belief with one correction that accounts for the shape of quantum reality. And the size of that correction is set by the dimension d. This is where something genuinely uncanny enters, and I want to present it neutrally, because it is a fact about mathematics, not yet an argument about anything. That dimension, d, the number that sets the size of the quantum correction, is treated by the QBists not as a description of how much an agent knows, but as a real capacity that a physical system holds entirely by itself. Fuchs has compared it directly to mass, the way, in Newton's physics, a body simply has a mass, a quantity it carries regardless of what anyone believes about it. Dimension, Fuchs writes, is something a body holds all by itself, regardless of what an agent thinks of it. He has gone so far as to call the structure that arises from SICs a kind of QBist Planck's constant, a fundamental dimensional fingerprint of the quantum world. Mark this carefully, because there is a tension here we will return to. A theory that says the quantum state is mere personal belief nonetheless reaches out and grabs one quantity, dimension, and insists it is objective, out there, a property of the body and not of the mind. Even the most subjective interpretation cannot make everything subjective. Something stays stubbornly real. Keep that. And now the part that should genuinely stop you. The question of whether SICs even exist, whether these perfectly symmetric arrangements of d-squared points can be constructed in every dimension, turns out to be one of the hardest open problems in pure mathematics. A physicist named Gerhard Zauner conjectured in his doctoral thesis in 1999 that they exist in every dimension. More than a quarter century later, that conjecture is still not unconditionally proven. SICs have been constructed exactly in dimensions 1 through 21, and in a scattering of higher dimensions, 24, 28, 30 and others, up to 323 and beyond, and found numerically in every dimension checked up to 151, with related computations reaching dimensions of several hundred and beyond. But a general proof resisted everyone. And when mathematicians finally traced why it was so hard, they found themselves staring at a connection no one had any right to expect. The existence of these symmetric quantum measurements is bound up with Hilbert's 12th problem and with the Stark conjectures, questions in algebraic number theory about the deep structure of certain number systems, questions about real quadratic fields, questions that have nothing on their face to do with measuring an electron. In January of 2025, 3 mathematicians, Appleby, Flamier and Kopp, published a constructive approach to Zorner's conjecture by way of the Stark conjectures, giving, for the first time, an exact solution in dimension 23, a dimension that had resisted for years. It is a conditional result. It rests on an unproven conjecture in number theory plus a technical identity. And I will be precise about that, because honesty about what is and is not proven is the whole spirit of this examination. But the shape of the thing is unmistakable. A question about the simple act of measurement, about the geometry of observation, reaches down and touches some of the most rarefied and orderly structures in all of mathematics. What does it mean that the act of observation, formalized, leads not into chaos, but into the cathedral of number theory? Hold that question. We are not ready to answer it, but we will not forget it. There is a second front on which QBism makes its boldest, most contested claim, and it concerns the single word that has haunted quantum mechanics since Einstein first recoiled from it: non-locality. The story begins with a thought experiment and ends in a Nobel Prize, and you need its outline to see what QBism is doing. In 1935, Einstein, together with Boris Podolsky and Nathan Rosen, pointed out that quantum mechanics predicts a disturbing kind of connection between particles. Prepare 2 particles together in what is called an entangled state. Then carry them light years apart. Measure one, and the quantum formalism instantly assigns a definite expectation to the other, as if the act here reached across the void and settled something there. Einstein called it spooky action at a distance, and he believed it showed the theory was incomplete. He proposed a criterion of reality. If, without disturbing a system in any way, you can predict with certainty the value of some quantity, then there must be a real, pre-existing element of the world corresponding to that quantity. Entanglement, by that criterion, seemed to demand hidden properties the theory failed to mention. In 1964, the physicist John Bell turned this philosophical worry into mathematics and into something testable. Bell derived an inequality, a limit on how strongly the results of measurements on 2 separated particles could be correlated if the world obeyed 2 reasonable-sounding assumptions. The first was locality, that nothing influences anything faster than light. The second was realism, that the measured properties existed beforehand. Local hidden variable theories, theories that honor both assumptions, must obey Bell's limit. Quantum mechanics predicts that limit is violated. One specific version of the inequality, the one experimenters actually use, is called the CH-SH inequality, after Clauser, Horn, Shimoni, and Holt. It says a certain combination of correlation measurements, called S, must stay within an absolute value of 2 for any local realistic world. The absolute value of S is less than or equal to 2. Quantum mechanics predicts S can climb higher, up to a ceiling of 2 times the square root of 2, approximately 2.828, a value known as the Tsirelson bound, derived by Boris Tsirelson in 1980. Not infinitely high, there is a further algebraic maximum of 4 that pure signaling would allow, and nature does not reach it. Quantum correlations are stronger than any classical world permits, and yet weaker than the absolute limit. They sit at a precise, peculiar value, and why nature settles on exactly 2 times the square root of 2, no one has fully explained from first principles. File that number away with the others. Then came the experiments, and they are worth naming, because abstractions should be anchored to real events. In 1972, John Clauser, working at Berkeley, performed the first experimental test of Bell's inequality. He found the violation, though loopholes remained. In 1982, at Orsay in France, Aspect tightened the test with rapidly switching analyzers, so the choice of measurement was made too late for any slower-than-light signal to coordinate the results. In 1998, in Innsbruck, Anton Zeilinger's group, with Gregor Weiss, closed the locality loophole under strict conditions. And in 2015, 3 teams at Delft in the Netherlands, at the American Standards Institute, and in Vienna performed the first loophole-free Bell tests. The Delft experiment separated 2 electron spins by 1.3 kilometers, about 0.8 of a mile, and recorded an S of 2.42, plus or minus 0.2, a clean violation, with the detection and locality loopholes shut at the same time. In October of 2022, Aspect, Clauser, and Zeilinger shared the Nobel Prize in Physics for this body of work. The Nobel Committee's own summary said their experiments had shaken the very foundations of how we interpret measurements. The correlations are real. The violation is real. Something about the world is not locally realistic. The only question is which word to surrender, locality or realism. Almost everyone surrenders locality. The popular story, the one in every documentary, is that the particles are mysteriously connected across space, that measuring one instantly affects the other. QBism makes the opposite choice, and this is its sharpest knife. The QBist keeps locality and surrenders the specialized notion of realism, the pre-existing outcomes, the Einstein criterion. Here is the reasoning. For the QBist, a measurement outcome is an experience of a single agent. The correlations of a Bell experiment are correlations between outcomes, but no single agent ever experiences both outcomes at once, because the 2 measurements happen at space-like separation, in regions neither of which can send light to the other. A single agent can only ever stand in one place, gather one set of results, and update one set of beliefs. When the agent at one station measures her particle, nothing physical happens at the other station. Only her expectations about what she would experience were she to travel there and ask are updated. The light cone, the rule that no agent and no signal moves faster than light, is what grounds the locality. The trajectory of any agent through space-time is necessarily slower than light, and so quantum mechanics never assigns a correlation to two events that no single agent could ever jointly experience. Fuchs, Mermin and Schack put it flatly. Quantum mechanics is explicitly local in the QBist interpretation, and that is all there is to it. Notice the move, and notice that we are still only reporting it. The famous spookiness, the apparent action at a distance, evaporates, but only because the outcomes were never objective facts about the particles in the first place. They were experiences waiting to happen to agents. Erase the assumption that the measurement reveals a pre-existing property, and the non-locality you have to swallow vanishes with it. This is elegant. It is also exactly the assumption that outcomes are agent experiences rather than world facts that we have flagged twice already and will put on trial in the end. The QBist buys locality with a currency we have not yet checked for counterfeit. There is a famous theorem that seems, at first glance, to slam the door on any view like QBism, and intellectual honesty requires that we present it. In 2012, 3 physicists, Pusey, Barrett and Rudolph, proved a result often summarized in headlines as "the wave function is real." The PBR theorem appears to show that the quantum state cannot be merely a description of incomplete knowledge, that it must correspond to something objectively physical. If that were the end of the story, QBism would be dead on arrival. But it is not the end of the story, and the reason is subtle and important. The PBR theorem proves its conclusion inside a particular mathematical framework, one that assumes each preparation corresponds to a single, objective, underlying physical state, a hidden variable, and that independently prepared systems are independent in a specific technical sense. QBism does not live in that framework at all. The QBist state is not a distribution over hidden physical states. It is a doxastic object, a degree of belief, which the framework's assumptions simply do not describe. The theorem's premises do not apply, and, remarkably, Pusey, Barrett and Rudolph said as much themselves, noting at the end of their own paper that their result does not touch interpretations like this one. So the matter is not settled either way. Physics has not proven the wave function real, and it has not proven reality mind-made. It has proven that if you make certain assumptions, the state is real, and QBism declines those assumptions. Remember this the next time someone tells you science has decided the question. It has not. Now we arrive at the thought experiment that pushes every interpretation to its breaking point. The one where QBism either shines or shatters. It began in 1961 with Eugene Wigner, and it is called Wigner's Friend. Imagine a laboratory, sealed. Inside, a physicist, the friend, performs a quantum measurement and gets a definite result. From the friend's point of view, the measurement is over. An outcome has happened. But outside the lab stands Wigner, who has not yet opened the door. For Wigner, the entire laboratory, friend, instrument and all, is one big quantum system that he has not measured. So Wigner, following the formalism, describes the sealed lab as a superposition, a blend of all possible outcomes, none of them settled. Two observers. One says the outcome is definite, the other says it is not. They cannot both be reading the same objective fact. In 2018, Daniela Frauchiger and Renato Renner sharpened this into a genuine theorem, an extended Wigner's friend scenario with multiple agents reasoning about each other's reasoning. And they proved something devastating. Under a few assumptions that feel almost too obvious to state, the agents are driven to contradictory conclusions. The standard reading is that quantum mechanics cannot consistently describe agents who themselves use quantum mechanics, that observer-independent facts collapse into paradox. It is one of the most discussed results in the foundations of physics in this century. Watch what QBism does with it, because this is the interpretation operating at full power. For the QBist, there is no paradox, because there was never a God's eye view to be had. Each agent's measurement outcome is an experience belonging to that agent and that agent alone. The friend's result is real for the friend. Wigner's superposition is valid for Wigner, as a catalogue of his own expectations about what he will experience when he finally opens the door. They do not contradict because they were never claims about the same observer-independent fact. There is no single third-person ledger of what really happened that both must match. Fuchs, with de Brotte and Schack, showed that the frauchiger-renner contradiction dissolves once Friend and Wigner are treated as agents on completely equal footing, what they call a quantum Copernican principle. No user of quantum theory is more privileged than any other. Each is, to the other, simply a physical system to be acted upon. The hidden assumption that generated the paradox, that one agent may take another agent's certainty and adopt it as her own fact, is exactly the assumption QBism rejects. And there is a vivid line for the deepest move in the paradox, the step where an agent must somehow treat herself as being in a superposition. The QBist says that step makes no more sense than trying to crawl inside a probability distribution and live there. You cannot be your own forecast. You can only have one. It is, I will grant fully, an impressive dissolution. Where other interpretations strain and bolt on machinery, QBism denies the premise that produced the trouble, the premise of a shared, observer-independent set of facts, and the trouble disappears. But sit with the cost. To make the paradoxes vanish, QBism has had to make reality, in a very specific sense, private. My measurement outcomes are mine. Yours are yours. There is no master copy. And this raises the question that QBism's own founders name as their deepest, most unsolved problem. The question the whole interpretation has been quietly deferring. And the question that will open the door to the final third of our examination. The question is this: if every agent has her own private stream of experience, her own outcomes, her own updates, then how is there a shared world at all? How do 7 billion private observers, each writing her own ledger, end up agreeing about a single sun, a single set of physical constants, a single solid table everyone can set a cup on? There has to be some reason. The world feels public when reality is, at root, first person. QBism's honest answer is that it does not yet have an answer. Rudiger Schack, in recent work, frames it precisely. There is never a necessity for two agents to agree on their outcomes. But an agent can strive to create conditions under which she would expect another agent's reported result to match her own. Agreement is not guaranteed by the structure of reality. It is something agents work toward and expect, and usually find. Mermin described how the privacy is bridged. Although I cannot enter your mind to share your perceptions, you can affect my perceptions through language. And through that exchange, we arrive at a common understanding of an external world, in spite of the privacy of our individual experience. But how a stable, shared, classical world reliably emerges from a theory of private experience remains, in Fuchs's own words, a project rather than a premise. The character of the stuff of the world, he and his colleagues write, is simply not yet understood well enough, and, they are careful to add, not because there is no stuff of the world, but because the goal is to understand it, not to assume it. Think about an ordinary human situation, because it makes the gap visible in a way the equations cannot. Picture two people who spend a life together, a long marriage. Each has only their own private experience. Neither can climb inside the other's head. And yet, across decades, through 10,000 conversations, they build something that feels like a shared world. Shared memories, shared meanings, a home both inhabit. The analogy is warm, and it is real, and for most of the way it fits QBism perfectly. A common world assembled out of private experiences, stitched together by language and action. But press it and feel exactly where it breaks. The marriage works because there already is a shared world underneath it. Two bodies in one house. One sun rising for both. One physical reality that anchors the 10,000 conversations and guarantees they are about the same things. Remove that common ground, make the shared world itself the thing to be explained, and the analogy stops carrying weight. Two private streams of experience, with no pre-given common reality beneath them, have nothing to guarantee they ever converge. The very thing that lets the marriage build a shared world is the very thing QBism says we may not assume. That breakdown is not a flaw in the analogy. It is the unsolved problem itself, made visible. What does it mean that the most subjective interpretation of physics cannot, from its own resources, explain the one thing every one of us experiences without effort, a world we all share. There is one more resonance to lay on the table before we turn from presentation to examination, because it widens the question from physics into the science of mind. In recent decades, the neuroscientist Carl Friston has developed a sweeping framework called the free energy principle, and its picture of an agent is hauntingly close to QBism's. In Friston's account, any self-maintaining system, a cell, a brain, a person, works to minimize a quantity called variational free energy, which is roughly a measure of surprise, of the gap between what the agent expects and what it encounters. The agent does this in two ways: by updating its beliefs to match the world, and by acting on the world to make the world match its beliefs. Written formally, the free energy, F, is the difference between the agent's expectations and the way the world actually is. And the agent's whole activity is the minimizing of that gap. It is a Bayesian loop of perception and action. And that is precisely the shape of the QBist agent, who updates her beliefs by experience and acts upon the world to bring about the experiences she expects. I must be careful here, and I will be. The formal links between QBism and the free energy principle are sparse in the literature. This is a structural resonance, a parallel in shape, not an established bridge. But the parallel is striking, and it points at something. Two of our deepest attempts to describe an agent, one from the foundations of physics, one from the foundations of neuroscience, both place a believing, acting, experiencing subject at the center, and both find that they cannot eliminate that subject without the whole description collapsing. What does it mean that when our best theories reach for the bottom of the world, keep finding a someone there? We have now laid out QBism fairly and in full. Its philosophical roots in James and Mach, its core claim that the quantum state is personal belief, its mathematics of symmetric measurements and the primal equation, its local reading of Bell's theorem, its dissolution of the measurement paradoxes, and its one great unsolved problem. For the length of this presentation, I have played the reporter, stating what proponents argue without testing it. That ends now. Earlier I said we would return to certain assumptions. We return to them now. The question is no longer what QBism claims. The question is whether those claims survive scrutiny, and where exactly the honest physics ends and the overreach begins. We begin the cross-examination with the claim that QBism is most often dragged into supporting. The claim you will find in 100 breathless videos and 1,000 comment threads. The claim is that quantum mechanics, and QBism in particular, has shown that there is no objective reality, that reality is a human construct, that the universe exists only in your mind, that nothing is real until you look at it. Proponents of this reading point to exactly the features we have spent an hour laying out: the dissolution of the measurement problem, the locality argument, the outcome that does not pre-exist the measurement. If the measurement creates the experience, they say, then you create reality. The mind makes the world. Present the claim in its strongest form, and then examine it honestly. because the most important thing I can tell you in this entire examination is that this popular claim is not what QBism says. It is a misreading, and the misreading fails not on theological grounds, but on the plain text of the theory itself. The founders of QBism state explicitly and repeatedly that the existence of an external world is a central postulate of their interpretation. Fuchs has written that QBism is a full-throated rejection of metaphysical solipsism. Solipsism being the doctrine that only your own mind exists. The QBist agent acts upon a world she did not create and cannot wish away. Her measurements are interventions into something genuinely external, something that pushes back, something that surprises her. The whole point of an experience in this framework is that it is an experience of an encounter with a reality outside the agent. The outcome is not invented by the mind the way a daydream is invented. It is brought forth in a collision between the agent and a world that is really there. So, when someone tells you that physics has proven reality is just in your head and cites QBism to do it, you are watching an argument defeat itself, because it has misunderstood the very theory it leans on. This is the rhetorical move philosophers call building on sand. The anti-realist takes a careful, limited claim that the quantum state describes an agent's expectations rather than the world's hidden properties, and inflates it into a sweeping metaphysical denial of the external world, a denial the theory's own authors forbid. Strip the inflation away, and what remains is far more modest and far more interesting. Not that there is no world, but that our most fundamental physical theory may be, in its deepest part, a manual for an agent's engagement with a world whose ultimate character we do not yet understand. That is not the abolition of reality. That is an admission about the limits of one particular description of it. And notice what this does to a different anti-theistic claim. The materialists claim that the observer is a convenience we will eventually eliminate, that consciousness is nothing but matter in motion, that the first-person point of view is a kind of illusion physics will one day dissolve into pure third-person mechanism. Here QBism cuts hard against the materialist, and this is the heart of the matter. QBism does not eliminate the observer. It places the observer, the agent, the experiencer, at the absolute center of the most successful physical theory ever devised, and it finds that the observer cannot be removed without the theory losing its meaning. The agent is, in the QBist's own admission, undefined and yet indispensable. You cannot write down the theory without her. The probabilities are her probabilities. The outcomes are her experiences. The updates are her updates. Take her away, and there is nothing left to interpret. Examine what this implies and follow the logic without flinching. For 3 centuries, the dream of a complete physics was the dream of a world fully described from no point of view at all. A God's eye account in which every fact is laid out on a single objective table, and the observer is just one more object on it. A clever arrangement of particles with no special standing. The whole momentum of materialism rides on that dream. If everything, including you, is just matter described from the outside, then mind is a leftover, a byproduct, an illusion soon to be explained away. And here is the prosecution's exhibit. Our deepest theory of the physical world, pushed to its most careful interpretation, will not give us that view from nowhere. It keeps handing us back a someone. The agent will not reduce to an object. The first-person perspective will not flatten into the third. What does it mean that the materialist program, at the very frontier of physics, runs into a subject it cannot dissolve? This connects to the deepest unsolved problem in the science of mind, what philosophers call the hard problem of consciousness. Neuroscience can map in exquisite detail which brain states accompany which mental states. It can tell you which neurons fire when you see red, which regions light up when you feel pain. What it cannot do, what no amount of mapping has ever done, is explain why there is something it is like to see red at all. Why the firing of unconscious neurons is accompanied by an inner experience rather than by nothing, by darkness, by mere mechanism running blind. Matter, as physics describes it, is not conscious. A particle has no inner life. An arrangement of particles, however clever, is still an arrangement of particles. To say that consciousness emerges when the arrangement gets complicated enough is not an explanation. It is a label placed over a gap, a promissory note that materialism has been writing for a century and has never once cashed. And here is the inversion that should make the materialist pause. He wants to say the mind is nothing but an arrangement of matter. But our most fundamental account of matter, in its most careful form, turns out to require a mind, an experiencing agent that it cannot itself explain. The thing that was supposed to be derivative shows up at the foundation. The thing that was supposed to be fundamental cannot do without it. I want to be scrupulously fair here, because that is the whole spirit of this channel. QBism does not prove the existence of a soul. It does not prove the existence of God. A QBist physicist may be a thoroughgoing atheist, and many are, and they would object strenuously to the use I am making of their theory. So let me state exactly what the argument is and is not. The argument is not that QBism establishes an intelligent cause. The argument is that QBism removes a weapon from the materialist's hand and places it in the other side's. The materialist claimed that physics would, in the end, give us a complete world with no irreducible observer in it, that mind would be shown to be nothing but matter. QBism, one of the most sophisticated readings of the most fundamental physics we have, suggests the opposite, that you cannot even state the theory without an experiencing agent at its core. That does not prove design, but it shatters the confident materialist promise that the observer was always going to be explained away. The observer is still here, at the bottom of the world, exactly where the materialists swore he would not be. There is a rival interpretation that points in precisely the opposite direction, and the contrast is the next piece of evidence, because it concerns one of the most popular escape routes in modern thought, the multiverse. The interpretation is called many worlds, proposed by Hugh Everett, and its claim is the boldest in all of physics. It says the wave function never collapses at all, that every possible outcome of every quantum measurement actually happens, each in its own branch of a constantly splitting reality. You did not get one result, you got all of them in parallel worlds. And the version of you reading these words is merely one branch among uncountable others. From this picture flows a particular metaphysical comfort for the materialist. If everything that can happen does happen, then there is no need to explain why this configuration of the universe rather than another. No need for choice. No need for design. No need for a chooser. The appearance of fine-tuning dissolves into a selection effect. Of course, we find ourselves in a life-permitting world, the argument runs, because there are infinitely many worlds, and we could only ever wake up in one that allows us to wake up. Now set QBism beside it, because the two are not gently different. They are, in the words of QBism's own founders, genuinely contradictory. Where many worlds multiplies reality into infinite branches to keep the wave function real and objective, QBism keeps a single world and denies the wave function was ever an object at all. Where many worlds says every outcome occurs, QBism says one outcome occurs, the one the agent actually experiences, and the others were only ever expectations that did not come to pass. Fuchs, drawing on William James, calls the QBism world a pluriverse, in a very different sense than Everett's. Not a branching tree of parallel actualities, but a single, unfinished world in which the future is genuinely open, in which the agent's free action helps write what comes next, and in which, this is James's phrase, which Fuchs quotes with feeling, nothing is irrevocably settled, and all action matters. He contrasts this directly with what he calls the monistic dead world of strict determinism, the block in which, as the poet had it, not all our tears can wipe out one word of the eternal script. And here is the prosecution's point about the multiverse, sharpened by this contrast. The multiverse is invoked to make design unnecessary, to explain fine-tuning without a fine-tuner. But notice the structure of the move. There is no observation of any other world. There never has been. No instrument has detected a parallel branch. No experiment could, even in principle, because the branches are defined as causally sealed from one another. The multiverse is not a finding, it is a postulate, invented precisely to absorb the appearance of design, an unfalsifiable entity proposed for the express purpose of avoiding a conclusion the evidence might otherwise suggest. Turn the atheist's favorite accusation around and look at it. Theists are charged with invoking a god of the gaps, a being summoned to plug the holes in our knowledge. But an infinity of unobservable universes, conjured into the argument at exactly the moment fine-tuning becomes uncomfortable, is nothing less than a naturalism of the gaps, a far more extravagant act of faith, multiplying entities beyond all evidence to keep a conclusion at bay. And QBism's existence as a serious single-world alternative is itself the rebuttal to the claim that physics forces the multiverse upon us. It does not. Here is a rigorous interpretation, taken seriously by working physicists, that keeps one world and one open future. The multiverse is a choice, not a necessity, and it is a choice made, often, to avoid precisely the inference we are tracing. Let me return now to a thread I asked you to hold much earlier, the strangest fact in all of this, the one about mathematics. Recall what we found. The symmetric measurements at the heart of QBism's reconstruction, the SICs, turned out to exist only by grace of some of the deepest and most orderly structures in pure number theory. Hilbert's 12th problem, the Stark conjectures, the arithmetic of real quadratic fields. A question about the bare act of observation, about the geometry of a measurement, reached down and touched a cathedral of abstract order that mathematicians had been building, for entirely unrelated reasons, for over a century. And recall the other number that Cyrilson bound, the precise ceiling on quantum correlations, 2 times the square root of 2, stronger than any classical world, and yet weaker than the logical maximum, sitting at a value no one has fully explained from first principles. What does it mean that the act of measurement, when you follow it all the way down, does not bottom out in noise? It would have been one thing if probing the foundations of observation led only into formlessness, into brute randomness, into a flaw of meaningless chance. That is the picture the materialist expects, turtles of accident all the way down. But that is not what we find. We find structure. We find that the simplest questions about measurement are knotted to the most refined and beautiful order in all of mathematics. Order so deep that proving a quantum measurement exists in every dimension requires conjectures about the hidden symmetries of number itself. Consider a locksmith takes apart the cheapest, most ordinary padlock, expecting to find a crude spring and a bent pin, and discovers inside it the most intricate clockwork ever made. Gears within gears, cut to a tolerance no human hand could match. The whole mechanism resonating with mathematics that took the species 2,000 years to uncover. He would not conclude that the padlock assembled itself. He would conclude that something with extraordinary knowledge had been there first. The order in the foundations of measurement does not prove a designer the way a fingerprint proves a hand, but it is exactly the kind of thing, precise, deep, mathematically lawful, unreasonably effective, that points toward intelligence rather than away from it. Order of this caliber is the signature of mind, not of accident. And then there is the most honest piece of evidence of all, and it comes not from the critics of QBism, but from its founders. I have been at pains throughout this examination to separate what QBism genuinely claims from what its popularizers inflate it into. But the QBists themselves are the most candid witnesses to the limits of their own theory, and to the limits of naturalistic explanation in general. Christopher Fuchs, the principal architect of the interpretation, has said that even QBists have only the thinnest glimmer of the reality their theory points to. He and his colleagues write that QBism is, on the nature of the stuff of the world, so far mostly silent. Not, they insist, because there is no stuff of the world, but because its character is simply not yet understood well enough. And that understanding is the goal of the project. This is the opposite of the confident materialist promise that science has explained or will shortly explain everything that needs explaining. The most sophisticated interpretation of quantum mechanics arrives after a century of the hardest thinking, at a frank confession of mystery at the foundation. A mystery the founders themselves locate exactly where the experiencing agent meets the world. When a materialist tells you that science will eventually close every gap, that the observer and consciousness and the nature of reality are just engineering problems awaiting solution, remember that the people who understand this physics most deeply say no such thing. They say there is a thinnest glimmer, and a project, and a question not yet answered. Honesty about the limits of explanation is not a weakness of the science. It is the science at its most truthful. And it is precisely at that truthful edge that the materialist's promissory note comes due and cannot be paid. Let me press the materialist on the one move he has left, because a careful thinker will see it coming. He may say, very well, grant that QBism puts an agent at the center of the formalism. That is a fact about our description, not about the world. The agent is a bookkeeping device, a label for a complicated physical subsystem, a brain, a measuring apparatus. And one day we will replace the talk of agents and experiences with a fully mechanical account, and the observer will be revealed as nothing but neurons after all. This is the materialist's last redoubt, that the first-person language is provisional, a scaffolding to be kicked away once the real third-person physics is finished. Follow that claim to its end and watch it consume itself. Suppose the materialist is right that the experiencing agent is an illusion, that there is, at bottom, no genuine first-person point of view, only mechanism mistaking itself for a self. Then consider what science is. Science is a structure built entirely out of observations, out of experiences had by agents, recorded by agents, compared between agents. Every datum is someone's experience of a dial, a screen, a click, a mark. If the experiencing agent is an illusion, then the observations that constitute the entire evidential basis of physics are illusions too, and the physics built on them, including the very materialist theory being used to declare the agent illusory, rests on a foundation it has just dissolved. The argument that consciousness is an illusion is itself a thought, entertained by a consciousness, justified by appeal to experiences. If those experiences are not real, the argument has no premises. If they are real, its conclusion is false. This is the reductio, and it is fatal. Eliminative materialism, pushed to its logical end, eats the empirical evidence that was its only authority. QBism, far from rescuing the materialist here, makes the self-defeat vivid, because QBism shows that even our most fundamental physics is, structurally, a theory of an agent's experiences. You cannot use a theory of experience to prove that experience is unreal. I find this the part that stays with me. Not the mathematics, though the mathematics is beautiful, but this. When we built the most precise instrument of impersonal objective knowledge the species has ever possessed, and turned it to its sharpest point, and asked it what lies at the very bottom, it did not answer with a mechanism. It answered with a someone. The view from nowhere, the dream of a complete account of reality with no one in it, turns out to be a view we cannot actually occupy. There is always a perspective. There is always an experiencer. We keep trying to step outside ourselves, to see the world as it is in our absence. And we keep discovering that the stepping outside is itself something we do, from somewhere, as someone. The observer is not a smudge on the lens to be wiped away. The observer may be part of what the lens is looking at when it looks all the way down. Pause here before we draw the threads together. Take a moment and ask yourself, honestly, what you would conclude from this pattern if you had no prior commitment either way. A philosophy that says experience comes before the split into subject and object. A physics that, a century later and entirely independently, finds it cannot describe the world without an experiencing agent at its core. A neuroscience that, reaching for the foundations of mind, finds the same believing, acting subject staring back. A mathematics underneath the act of measurement so deep and ordered, it took the species 2,000 years to begin to map it. And the honest admission from the people who know this physics best, that the nature of the world and the nature of the agent remain a mystery they can only glimpse. Follow that evidence with no thumb on the scale and consider where it points. Consider one more everyday picture, because the question of the agent deserves to be felt and not just argued. Think of what it is to teach a child to speak. You do not install language in the child the way you load a program into a machine. You speak, and the child is there, already a someone, already an experiencer, already a center of a point of view, and meaning passes between two centers that can never merge. The child learns your words, and slowly the two of you come to share a world, the same names for the same things, a common reality built across the gap between two private minds. It is the most ordinary miracle there is, and it is, almost exactly, Mermin's account of how QBist agents bridge the privacy of experience through language. The analogy fits, and it is moving. But now press it to its breaking point, the way an honest examination must. The teaching works because the child is already a subject, already someone for whom there is something it is like to hear a word. That subject had to come from somewhere. You did not manufacture it out of matter. It was there to be spoken to. And this is exactly the place QBism's materialist readers cannot follow the analogy, because their whole program requires that the subject be built, late and accidentally, out of unconscious stuff. And yet every act of teaching, every act of measurement, every act of science presupposes a subject already present to do the experiencing. The analogy breaks at the agent. It always breaks at the agent. The first-person point of view is never assembled in front of us out of parts. It is always already there, the precondition of every assembly. What does it mean that the one thing our theories cannot derive and cannot do without is the experiencer at the center? This is the cascade, And let me lay the steps out plainly, because the conclusion is built from them in order. If the quantum state is the belief of an agent, then an agent is presupposed by the foundations of physics. If the agent cannot be eliminated without the theory and its evidence collapsing, then the experiencing subject is not a derivative accident, but a basic feature of any account of the world we can actually give. If the experiencing subject is basic, then materialism's central promise, that mind is nothing but matter to be explained away, is not a finding but a faith, and a faith now running against the grain of the physics. And if mind is woven into the foundation of things, rather than thrown up late by accident, then the question of where that mind-suffused order comes from cannot be waved aside. A universe whose deepest description requires an experiencer, whose act of measurement opens onto the most refined mathematical order we know, whose own most expert students confess they have caught only the thinnest glimmer of what it ultimately is not the cold, mindless, self-explaining machine the materialist promised. It is something stranger, and something far more suggestive. The order did not write itself. The mathematics did not lay its own foundations. The experiencing agent did not assemble itself from particles that have no experience to give. Each of these points on its own an honest skeptic might absorb. But ask the question the materialist most wants to avoid. What is the name for a convergence of this magnitude? Philosophy, physics, mathematics, and the science of mind, all independently arriving at a subject and an order they cannot explain from below. Coincidence is the name you reach for when you have decided in advance what you are not allowed to conclude. Before we draw the threads together, weigh one last body of evidence, the testimony of the witnesses themselves, because there is a particular kind of admission that carries more weight than any argument. It is the admission that costs the one who makes it. When a defender of a position concedes a difficulty, when an expert who has every professional incentive to project confidence instead confesses a limit, you are watching something rarer than rhetoric. You are watching honesty under pressure. And the literature of QBism is unusually rich in it. Consider N. David Mermin, a distinguished physicist at Cornell, a man who had spent years developing his own interpretation of quantum mechanics. He called it the Ithaca interpretation, built on the slogan that correlations have physical reality, while the things they correlate do not. That was his position, his contribution, the view that bore his intellectual fingerprint. And then, confronted with results that undermined it, Mermin did the thing that is hardest for any thinker to do. He abandoned his own view and converted to a rival. In 2012, in the pages of a physics magazine, he wrote that he found QBism by far the most interesting game in town, adding with dry honesty that it had not been enthusiastically received by the quantum foundations community. A man does not surrender the interpretation that carries his name unless the pull of an idea is very strong. That conversion is a datum. It tells you this is not a fringe fancy, but a position serious physicists feel compelled toward, against their own prior commitments, and against the fashion of their field. Consider, too, the words of the physicist E.T. Jaynes, quoted approvingly by the QBists, on the deepest puzzle of the formalism. Our present quantum theory, Jaynes wrote, is not purely a description of nature. It is a peculiar mixture describing in part realities of nature, in part incomplete human information about nature, all scrambled up by the founders into an omelette that nobody has seen how to unscramble. An omelette nobody has seen how to unscramble. That is a working physicist, decades into the project, admitting that we do not cleanly know which part of our best theory is the world and which part is us. The materialist tells you the world has been disenchanted, laid bare, reduced to mechanism. The physicist who looks most closely says, we cannot yet separate the world from the observer in our own equations. What does it mean that a century of the hardest thinking has not been able to take the watcher out of the watched? And consider the verdict of the highest tribunal in the field. When the Nobel Prize in Physics was awarded in 2022 for the experiments that confirmed the violation of Bell's inequalities, the committee did not say the work had tidied up a loose end. A member of the committee said the laureates' work had shaken the very foundations of how we interpret measurements. Shaken the foundations. That is, the establishment of physics, in the act of its highest honor, conceding that the meaning of measurement, the simple act at the center of this entire video, is not settled, not secure, not understood. These are not the words of cranks or mystics. They are the candid admissions of the people who know this physics most intimately, and every one of them points the same way, toward a foundation that remains open, a watcher that will not be removed, a mystery exactly where the agent meets the world. Let me bring this exploration to a close. We began with a philosopher who said the world is not first divided into mind and matter, that beneath the split between the observer and the observed lies a single stuff, pure experience, which William James placed before everything else. We followed that idea through Ernst Mach's refusal to grant reality to the unobserved, through Bruno de Finetti's claim that probability is not in the world, but in the believing mind, and into the heart of the strangest theory in physics. There we met Quantum Bayesianism, QBism, and its austere proposal that the wavefunction is not a thing in the world, but an agent's personal expectation, that a measurement does not uncover a fact, but brings forth an experience, that the famous collapse is nothing but a mind revising its forecast. We saw the mathematics, the symmetric measurements, the SICs, the primal equation that bends ordinary reasoning by a single-dimensional twist, and the uncanny way that the existence of those measurements reaches down into the deepest order in number theory. We saw QBism keep locality where everyone else surrenders it, dissolve the measurement paradoxes by denying there was ever a single objective ledger, and slip past the theorem that was supposed to prove the wavefunction real. And we saw it arrive, honestly, at the one question it cannot answer: how a shared world is built from private experience. Then we tested the claims, and the evidence, examined without a thumb on the scale, did not point where the popular story promised. It is not true that QBism shows reality to be a figment of the mind. The theory postulates an external world and rejects solipsism in its founder's own words. What is true is sharper and stranger. Our most fundamental physics, pushed to its most careful interpretation, cannot be written without an experiencing agent at its center, cannot eliminate the observer it was supposed to dissolve, and bottoms out not in noise, but in an order so deep that the people who know it best confess they have caught only its thinnest glimmer. The materialist promised a complete world with no one in it. The physics keeps handing back a someone. The materialist promised that the appearance of design would dissolve into infinite, unseen worlds. A single world interpretation, taken seriously by working physicists, shows that escape was never forced upon us. And the order beneath the act of measurement, precise, lawful, unreasonably beautiful, is exactly the kind of thing that points toward intelligence and away from accident. This is where the evidence leads, not to a proof that closes the mouth, but to a conclusion that the honest mind can no longer dismiss. The experiencing agent at the foundation of physics, and the deep mathematical order beneath the simplest act of observation, are far better explained by an intelligent cause, one with knowledge, with will, with the power to set the foundations of a world, than by the promise that unconscious matter, given enough time and enough luck, somehow wrote its own laws and woke up to notice them. The raw experience that meets the world is not the end of the inquiry. It is a clue, and the clue points beyond itself, to a mind that is not an accident of matter, because matter was never able to account for mind at all. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds. We have circled the participating observer all the way through this video, the agent who stands at the center of the measurement, the wave function read as personal belief, the framework Christopher Fuchs built around it. But there is a fuller account of that framework on its own terms, where it came from and how far its defenders take it. And I have followed it much further elsewhere. If the figure of the observer at the heart of reality, thread that stayed with you, you will find where it continues on the end screen now and in the description below. We came looking for the world as it is when no one is looking, and we found that we could not subtract the one who looks. The experience was always there first, plain, unqualified, a simple that, and woven through it an order we did not author and cannot yet fathom. Rest tonight inside a reality you helped to meet but did not make, held together by a mind that was there before the looking began. Good night.